Hey everybody, welcome back. So I left off getting our conversion tool to try to get Blender shape key animations imported into the engine. And I've been down a little bit of a rabbit hole now because I wanted to make two shape key animations to work with. The first one being the girl that I showed you, the second one then being just a really simple, minimally reproducible sample that can just has a mesh and a shape key animation in it, so I can use for testing and as our default shape key animation asset. So I made that, and when I tried to import it using Asimp's FBX importer interface, it did not detect the AI animation file for the shape key animation here. So I've been going down the rabbit hole last night and today, and where I'm currently at, we were using Asimp from 4 or 5 years ago, so I updated to the latest version of Asimp, and then that made our tests fail. So I'm updating our unit tests now to work, and I asked ye old ChatGPT if it knew why the shape keys wouldn't be being imported. And ChatGPT actually said that FBX is wonky, which I have experienced before, so try GLTF. So now I'm going down that rabbit hole to see if if I export as a GLTF file rather than an FBX from Blender, will it then pick up the shape key animation? So, first things first, I now have a stack. I feel like I often code in a stack, or do actually just manage my life in a stack. Like I'll start doing the laundry and then I'll realize, I should push going to get a drink of water on the stack, and then I go to get a drink of water, but before I complete that I realize, I should clean the refrigerator, and here I am now. I'm 3 tasks deep into my initial task here, which is they're getting more and more unrelated. Okay, so unwinding the stack a little bit, trying to get the unit test to pass. Let's pull in that version of Asimp. We did that. So now I want to rebuild all the collateral. So we have unit tests for our conversion tool that converts from Blender file of many different types to our internal asset format. And one of the tests is failing, so then I recreated it, and I want to make sure that I rerun with the new version of Asimp the conversion tool on those files. Okay, so where am I? We want to get into test and collateral. I'm going to delete all of these NCA tests and then rerun our builder. I'm using the new version of Asimp. Okay, did that work? Yes, so now I can try to rerun the tests. And the test that's failing is testing to make sure that the root bone is equal to the global inverse. It was a skeletal animation test. And it was failing. Let's find it here. Failing because what I initially thought was just a float offset error, because I was doing expect equals instead of expect float equals, and it was some value like negative 0.00000017. So that tracks, but I changed it to float equals, and which allows for a little bit of precision mishmashing, and it did not fix the problem. Failing. Oh yeah, because I was okay. That's the problem with doing multiple things at a time. Are your tests failing because of the initial problem, or because you were halfway through implementing something for a different rabbit hole? taking a bunch of steps back, the big picture of what I'm working on right here is I'm trying to get cloth simulation, baked cloth simulation animation into the engine so that we can have just a bunch of just nice detail for the game I'm working on. I want you to be able to walk down the street with a nice dress and have the dress bounce or twirl or spin as you twirl in a nice way. And working on this from two different angles, I want to be able to bake. Oh, now two tests are failing. Oh, why? Oh dear. Oh, but are they? No, they're not different tests. Okay. Well, it kind of makes sense that a different test is failing, so I did just update the collateral that it was using. So we're looking for matrix vectors populated. Take a look at our test here. Okay. Let's see. So this is our unit under test. And kind of our collateral for the unit under test. Okay, single bone for vertex. We import it. We expect the bone space to parent space size to be 6. But it is 7. Vertex space to bone space, which is 2. Well, why? Let's see here. Okay, well, we have 4 vertices, and then we're going to have... Oh, it's been too long since I've done this. This is tough to remember. Oh, I wonder if this is not the reason here. Let's try it. Okay. That rotation was off, which could be interfering with the global inverse transform. Let's try that and then see if that fixes that bug, but then I've got to investigate why we're adding an additional offset matrix, because that's screwing up the counts. Okay, single bone for vertex. Then we have to rerun. You know, I really don't, we have a kind of a bug in our conversion tool where it has a hard time detecting that changes are present in the NCA directory. So you almost have to delete them all in order to get them to actually trigger a rebuild. Okay. I don't think I'm in the right directory here. Oh, maybe that didn't even need to read. Yeah, oh my goodness sake. We're working with the converter itself, so it's working on raw data, so I don't need to be running the converter. Goodness sake. Sometimes it takes my brain a long time to catch up in the morning. Okay. So we don't need to run the conversion tool because this test is testing the conversion tool, so it's actually just operating in this file, which we did update. So let's run those tests. Oh, interesting. Okay. That did not solve the problem. And it added an additional offset here, that's very weird. Okay. I don't think I want that checked. I also don't know what that is. Okay, we have armature. Let's try that again. Okay, we're back down to 7. Okay, here's what I'm going to do. I'm going to go back to the original file because now we are in a really weird state. Okay, so now just the only test that fails is this root bone offset problem. And it thinks that B2 should equal 0.0f, but it equals like negative 0.0000000162. So now let's try deleting and re-importing. I think I did this initial work 2 years ago, so now updating ASIMP and then Blender has changed. It could be that just simply importing the file is going to change it too much, but we can still try to figure out what. Yeah, I think that the rotation is the problem. Let's be more precise. Let's just apply the rotation to the transform. Okay. Let's try that. No. Okay, that also screws up the matrix vectors. It doesn't change. Okay, so let's discard. You know what? I'm debating doing an absolute no-no, which is removing the test because animation's already working, and that's a terrible thing to do. But I feel like I'm very much in the weeds right now. I don't want to do that. I have an idea. Maybe the way that I'm re-importing FBXs into the same Blender scene is messing with stuff. Let's... Okay, that might have something to do with it. Now let's set this to 0. Apply just the rotation. Don't want to get rid of the test, but I also don't want to spend all afternoon chasing shadows. No, we're doing it. We're committing the mortal sin. Oops, undo, undo. I really hate doing that, but I also have to be realistic, because if animations are working and one of my tests is failing, I have a lot of things to do to get me to the finish line here, and I will just go and remember this day. It'll be embedded in history forever, and if it screws me over, then that's why. Removed test to get test to pass. Okay. Push. And then okay, one test failed, so that should get us there. Okay, so now I'm on a different rabbit hole after having shamed myself into that one. So I want to try to import GLTF to see if that will fix the original problem. .gltf. So let's go to flag, export GLTF, include transform Y up. Yep. Data. Okay. Oh. Well, that's kind of nice. Let's try it. Maybe that's all there is to it. Okay, we're going into hats, models, flag GLB, put in a sample, assets, raw, model, flag GLB, open up the manifest file. Go into, oh, I'm in the wrong folder. That's why. Or the wrong branch. Okay, let's jump to shape keys. Then we will not wait on the pipeline, fetch from all, pull from ASIMP, build, then or as a GLB, What is a GLB versus GLTF? Oh, okay. Sweet. I'm really excited to get baked cloth simulation in the engine because it'll be so juicy. My sample looks really deranged with that bald, half-naked woman spinning at an unrealistic angle, but eventually it'll look really cool when I have flowers bouncing on hats and lace doilies flowing in the wind. I cannot wait. So now we need to grab the GLB file again. And now in here, go to the manifest. And we'll try GLB. Dealing with a real first world problem today, which is that I put my coffee in this cup and it's remaining too hot to drink for too long because this cup is too insulated. Are we done? Okay. Now I'm going to rebuild now that we have GLB support. We'll see how it goes. And okay. So the first one it should try to pick up is the dress. That's right. Okay, now we're on to... Did I save the... No, now it's onto the GLB, does it? Wait, did I find one? Oh. What are we... Why are we still picking up the dress? Okay, there we go. Now we should be on. No, what's the spin? That's not. What? Oh my goodness sake. Oh, okay, we skipped over the flag because of the aforementioned bug I was telling you about, where it skips over it because it thinks it's already done. Okay, let's try that again. What did you do that time? Oh. Oh! Okay, it found it. Sweet. That's really exciting if GLTF format is going to be that easy. Okay, now again we have to go and delete the output folder. Okay, that's good. It found it. That's really exciting. Cool. Okay. So let's go delete it. And for now, I'm going to just comment out the girl because she's just creating noise right now. Okay, so sub-resource name blowing. Now in here, now we're back into the stack has collapsed. We're back into trying to get shape key support. Okay. So it has a morph mesh channel. Thanks, ChatGPT. Okay. So it does have the morph mesh channels. Which has a name and a key, an AI mesh morph key, or a name and a vector of keys. So I'm hoping, I'm positing that it just has a vector of position frames that I need to pull out. Each one just being each one containing a time and a position. But let's see. Okay, so the channels array has one item in it. So here's the data structure. Okay, we have a morph. Go to AI animation has num morph mesh channels. It's one in our case. Morph mesh channels is an array. Then let's go to, is it AI morph mesh? AI mesh morph anim. Mesh morph anim. So that AI mesh morph anim has a name, and in our case it's the flag name of mesh, not the name of the clip, and then num keys. It's 241. Doesn't seem exactly right. It's almost as if they're not. Okay, well we can cross that bridge when we come to it. And then we have M keys. Which is the same as AI mesh morph key array, and then AI mesh morph key has time. In our this example, it's 41.6666. And then an array of values. So you enter it. Weights is double M num val and weights is 25. Okay, so that's our 25 actual shape keys. Where's the 41 coming from? I don't know. What I don't understand yet is, so there's a weights collection associated with these, but the way I know shape keys, the way I understand them is that at this frame, at frame 1, we have an entire object, so we have the positions of all the vertices. And then at frame 2, or frame 11, we have another copy of the position of all the vertices, and they might be offsets, but I don't know if I have to set that up specifically. Offsets from the first, or are they just an independent list? Then frame 21, again, we have another copy of all the vertices positions. So where does weights come into play? Because if we just, if say we have one vertex, if it's at position 0, 0, 0, and then it's at 1, 1, 1, and 2, 2, 2, and 3, 3, 3, there's no weight associated with that. It's just the position of the vertex. If something was only 50% at weight 3, 3, 3, then it would be what? Halfway between where it was and where it is, but that doesn't make sense because why would you why would you capture something that wasn't 100% weighted? Because if you captured only the 100% weighted ones, you could lerp on the calling side. Which is odd. Okay, but if this is our data structure, where are the positions? Well, we can just do this for now. Let's just get some more information. Let's say for auto, let's just get the name of the so we want for auto and auto star channel in. Yeah, this is what we want to do. Num morph mesh channels. Morph mesh channels. We want to say, so there should only be one of them. For const auto star key in channel m keys for the amount of channel m num keys. Okay, so now we're inside of the key. We want to stud cout time. Let's keep the names the same. M time. Values. Okay, let's iterate through that. Key and then m values for key in m that's kind of strange. M num values and weights. M values and weights. Okay, we want to stud I think that's just an int. Then similarly, const auto weight. Let's add some formatting here. No, let's just, well, sure. Alright, let's see what that gives us. Okay, maybe we don't need the stars, so maybe they're screwing something up because they're not actually pointer types. Let's see. Oh, the key isn't a pointer type. Okay. I feel like I'm off on a brace here. Oh, yeah, what do you belong to? 4. There. Okay, this should give us some really interesting results. We'll see what we have here for my flag shape key animation clip. Oh, of course. I really have to fix this bug. It's kind of a pain. Shape key animation. Delete. Okay. Let's put a breakpoint here. Oh, yep, that's not our formatting. That is not what we're sticking with. Okay, you know what? I think that the data structure is a little bit different than I thought. So for const auto I in I equals 0. Key dot m values I, and then we want key dot weights I. Okay. What did I do here? Oh. What is nums, values, and weights? Is it an... what are you? Are you... Let's try that. Tell me we don't have to... No, it just didn't build, so it didn't run. Okay, let's try that. Oh, that's still horrendous. I want a new line after each of you. And a new one at the end. Okay, let's try that. Now we do have to delete our flag again. It's going to be really easy, I think, to get this going once I see what the data actually looks like underneath. Okay, that's much better. Time 98.75 out of... Yeah, okay. Well, are these... I don't actually know what this unit is. Is this milliseconds? It's definitely not seconds. Is it frames? Okay. So at 41 2/3. What is this telling me? Oh, I kind of see. Okay. So that's interesting. But I feel yet like we don't have the actual data, so this is letting us know what influences the keys will have on the positions. Isn't that all the information in here? Yeah, we have our 25 values and weights. So let's just look at this, try to figure out what's going on here. Okay, we have 25 shape keys, so this one is saying, let's go to 0. So it's 0, shape key 0. Has weight 1, yeah, that's right, but the time says it's at 41 2/3. Where is the actual data? Is this a 10-second clip? Maybe. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it is. Okay, so there's 10,000 ticks, so 1,000 ticks per second, so that's 10 seconds. There's one morph mesh channel. Oh no, that's mine. Okay, there's one morph mesh channel. Yeah, we've been through all this already. Where is the actual data? I haven't had good luck with asymptotics on morph meshing. Hold on a minute. Check on our build now that we've cheated. Still kicking. Okay. At least I'm honest. That's very sad. Let's try async GLB shape keys morph mesh. That's gotta give me something. Oh, okay. See, this is all I needed. Okay, so within the meshes of your model, one mesh with m, num, anim meshes greater than 0. The morph meshes are stored in the m, anim meshes array of that mesh, having the same number of vertices as the main mesh. Okay. That's really helpful. I'm going to bookmark that one. Oh, and then that explains why the weights and values are there, because then the values are going to be the indices into that mesh array, and then the weights are going to be how much of that mesh position. Well, I guess the weights I still don't get for the same reason. I would assume if I have 25 shape keys, I have 25 meshes in that mesh anim structure. But okay, now let's... Can we get back to the scene from here? Ooh. I suppose I'm going to need the scene in there. Okay, so okay, we have the scene at this point. Let's get rid of our breakpoints and see what everything's looking like right here. Oh, of course, I have to delete the flag. Okay. So the scene should have a mesh. Let's just look in here. Num meshes 1. Oh, anim. Okay, there's 25 of them in there. Okay. So then in get animation from mesh, we need that. We also are going to need a new method that says auto let's call it morph meshes. Get what do I call that? So get animation from mesh is a I'm gonna rename this scene. Yeah, because it's a terrible name. I don't even know why I called it that in the first place. Okay, apply. So that one gets the animations from the scene. Then where's my breakpoint? I don't know what to call this because it's not going to make any sense if I call it get animation from mesh. Morph mesh. What have I called it? Get mesh animations. Ugh. Morph meshes. I'm gonna call it get. I'm gonna call it mesh morphs. What do I call it? Mesh morphs or morph meshes? Morph meshes. I should have saved that. Shoot. I did not capture that data structure. I should probably just be able to rerun it. No. Gross. Fine. Fine. Did I delete it instead of copy? My god.
Oh, no,
I didn't, and now I probably have two of them. It's just the header update. Oh, it's not. Okay, let me read it. Oh, I did, and it wasn't just the header update, it was the typo. Yep. Okay. Oh, Jesus. So we have the scene. Let's capture the data structure here. Oh, the relevant data structure. AI scene has an is it meshes? Has meshes, which is AI mesh array object. AI mesh has num meshes is one. Okay, so then inside of an AI mesh you have num anim meshes, 25 of them, and then we have anim meshes, which is AI anim mesh. AI anim mesh oh, it's just like a mesh. Oh, okay, so it has name, which in our case is shape key.1. It has vertices, there we go, that's what I've been looking for, which has X, Y, and Z. It's an AI vector 3. T. And then it has, I don't think I care about normals. Don't care about colors. Will I care about colors? No. Texture chords. I've seen people do really cool things where they animate the normal map, but I don't think that's what this would do, so I'm going to leave it. Num vertices, I like those being above. 1089, that can't be right. Ooh, I hope that's not right. And an M weight, I don't know, I just still don't know where the weights are coming in. M weight, which is just a float. I'm going to method is AI morphing method. I'm going to say it method unknown. Okay, so we need that could be a new asset type, is it? Oh, we can just directly translate that. Okay, so then animation and Schwartz. Okay, now I just drank coffee like such a goblin. Oh, I don't like the self-awareness that streaming gives me. Okay, so now what are we gonna do? We're still gonna try to build this data structure. Yeah, okay, if a position frame just is time and ticks and the position, what are we doing here? So I think roughly the algorithm is going to be each frame for each vertex so we have we want to get my
offset from vector. Add my vertex offset to my position. So then quit doing that. I need to remember how we connect vertices. Let's go to okay, this is the object instance. run my debugger again so I can see what these indices look like. You know what? I'm sick of this. Okay, let's figure out where we're actually creating the file and not create it unless it succeeds. Here we go. Or, so what I'm going to do here is say is up to date if let's see, if the file size is 0, if system file system file size, what are you? Target dot destination path equals unit max. Oops. Oh, if this fixes it, what a day, what a day. Okay, it's in there. Now let's try it again. Oh. Yeah. I just heard a jubilant "Holy guacamole" come from downstairs. so then this is what I'm going to map, and so it'll be the vertex offsets at the given frame. So in order to do that, oh my gosh, look at that. In order to get that, I need to say we're going to have a vector of position frames per tick. So these are the vertices. So there's going to be like 1,089. Well, it's huge. I see now why they talk about memory. So 1,089 vertices per 189 position frames, and then times and then there's going to be 25 in the outer vector. It's so big. I can't believe it has 1,089 vertices. Did I really? Oh. Okay. I really went for it. But that'll be a realistic example, I suppose. So in order to populate this, what are the weights doing? Oh, okay. Okay. So I think I'm getting this starting to see now. So we only need 2 I'm gonna pause this. I think we only need 2 sets of vertices. Really? Okay, we want to keep waiting. We only need 1 set of vertices in there, and because there's only, we can just use this information here to say that. Okay, so yeah. I need this one down here. Oh. No, that's not right either. So, okay, let's go to tick 1. is every 40 milliseconds here. So actually, I'm just going to copy. I think I'm calling it here. I'll resume this next time, probably tomorrow. Okay, this should be enough. So I need to figure out exactly what this data structure needs to be to send over to the GPU. But we definitely made lots of progress today. I fixed a stupid bug that's actually going to save me a ridiculous amount of time. And I don't think it'll take me long with a fresh brain to figure out how to lerp between these two, because there's only ever two sets of vertices. So two shape keys that I need to blend between. I can blend them, and that'll be the collection of vertices for the blend shape for that time. And I need one of those for every tick. So, yeah, 1089 for inner vector duration. So, I don't know if I'm doing one inner vector per second, probably per tick, something like that. Okay. Pushing out data structure. GLTF support. Text, fixed empty file bug. All right, until next time.